All right, good afternoon and good evening to everybody on the East Coast. My name is Colton Marchessault and I'm the Program Director for Vertical Flight Society Arizona. I appreciate all the collaboration that we've had on this event, working together with the Philadelphia and Redstone chapters to bring in their members as well as giving updates on what they're going on. I'd like to start actually with allowing each of the chapter presidents or their delegates to go through and provide us that quick update. So we'll go ahead and start with the VFS Arizona chapter president, Tanya Reiner. So Tanya, if you have a quick minute, go ahead and let us know what's going on with VFS AZ.
Okay, great. Thank you, Colton. I also wanted to thank you personally for all of your efforts to organize this event. I know that there is much that transpires behind the scenes to pull these presentations off, like coordinating with headquarters to set up the GoToWebinar. And speaking of that, thank you, Chris from VFS headquarters, for all of your help. I'd also like to do a quick shout out to Connor Briggy, if he's online, for working with Colton to find and contact our invited speaker, Hector. And thank you, Hector, for taking time out of your busy schedule to give this presentation to our members today. And lastly, I'd also like to thank the Philadelphia chapter, Ada, and the Redstone chapter, Bill, for continuing to collaborate with us for these great virtual presentations. We are already starting to plan our next virtual tech talk, which will be in a few months or so. So please be on the lookout for that. I can't say too much just yet, but we are working on lining up a fantastic talk in the area of space and or perhaps rockets. So stay tuned for more information on that. And again, I'd also want to remind everyone about the upcoming VFS forum that is coming in May, coming up very quickly here. And think, this will be a fantastic forum with hopefully hundreds of attendees and speakers and technical presentations from all over the world. So really looking forward to that. Thank you, Colton.
Not a problem. Thank you, Tanya. It's been a fun effort always trying to get these presentations going on since we had to move to a virtual world. We're fortunate that this has actually been a fairly smooth transition, and we hope that it'll continue to be that way. We'll move on next to the Philadelphia chapter representative, Ada Walsh. She'll give us a quick update about the Philadelphia chapter. Go ahead, Ada.
Hey, everyone. Like Colton said, I am the VFS Philadelphia dinner meetings chair. So just a couple quick updates about for our chapter. I'd just like to remind everyone to, if you are interested in submitting an abstract for the VMS technical meeting that will be coming in August, hopefully it will be in person. If not, it will be virtual. Those abstracts are due April 30th. So you've got just about a month to get those in. And then also piggybacking off of what Tanya said about the forum, if you are presenting at forum and would like to practice your presentation, our VP of Tech Lunches, Joseph Gilman, is coordinating dry runs. So you have an opportunity to practice that ahead of time. So reach out to him if you'd like to practice. And that's all we've got on the docket for now. Hopefully we'll be having some more tech lunches soon and tech dinners. And I'd also like to thank Chris at headquarters and Colton for organizing all of this and all of the chapters. It's been great collaborating. So I'm glad we can continue doing this. And that's all I've got.
All right, thank you, Ada. It's great to have you back here again. All right, and Bill, we'll go ahead over to you for the Redstone chapter update. What you got?
Hey, good evening from Huntsville, Alabama. I'm Bill McCandless, the president of the Redstone chapter. We're excited that spring is here down here in Alabama. We actually had our first in-person board meeting today. We're hopeful that we'll continue to do a mix of virtual and in-person events. Especially as the Rocket City Trash Band has opened up with first pitch here in about 10 days. So the city's excited for those kind of things. We're also very pleased to continue to support the Army's efforts here for both future vertical lift assets. That's certainly the buzz in the technical world here in the area. We are on the hook for the next technical meeting. So that tech talk will be April 22nd. It'll be from Mr. Mark Ratliff, who's the Rapid Response Integration Manager, my former directorate that does airworthiness for Army Aviation. And the subject's going to be U.S. Army aviation policy for advanced manufacturing aircraft parts, components, and support products. So you'll see flyers out through your chapter for those things shortly. Again, thanks for having us. We're excited that we can continue to work together here to bring great content to all our chapters. Thanks, Colton.
Anytime, Bill. Thanks for joining us. And yes, absolutely, we will continue to look for those flyers. We'll distribute, of course, to our chapters, and we'll make sure that we kind of get them to the other interested groups as well. So thanks again. To all of our viewers today, I want to remind you that by default, your cameras and microphones have all been turned off. This is, of course, not to interrupt the presenter anytime. If you do have a question, I advise you to use either the questions dropdown or the chat dropdown and submit your questions. Towards the end of our 1 hour session, somewhere around 4:45 local or 7:45 Eastern, we will open up a Q&A session for about 15 minutes. Questions are intended to be answered in the order that they are submitted. I do intend to ask those questions to Hector, and then I will allow him to answer, and we will try to fit that all in there in the amount of time that we have. So without further ado, let's go ahead and introduce our speaker, and then we will get this presentation going. So Hector is the Honeywell Chief Technology Officer at the Unmanned Aerial Systems and Urban Air Mobility Organization. He leads a highly motivated and skilled engineering team in developing and integrating innovative, safe, and cost-effective technologies across the entire UAS and UAM ecosystem. He brings all of Honeywell's technologies and capabilities from the business and general aviation, air transport and regional, and defense and space industries to UAS, UAM, into the onboard vehicle systems, airspace, and ground operations for this new industry. His professional engineering career started in 1992. He has worked for a total of 4 aerospace companies throughout his career, each providing increasing levels of learned knowledge, growth, and skills in the following industries: defense, space, commercial air transport, commercial business aviation, general aviation, and most recently in urban air mobility. He is a certified Six Sigma Black Belt, fluent in Spanish, and leads the Honeywell Corporate Society of Hispanic Professional Engineers Inclusion, Diversity, and STEM for Science, Technology, Engineering, and Mathematics initiatives. So with that, I'd like to bring on our speaker, Hector Garcia. And Hector, whenever you're ready, it's all yours.
Thank you, Colton, and nice introduction. I wasn't thinking you were going to read the whole thing, but thank you. So welcome, everybody, and good afternoon, good evening. I hope that this information today will be very informative. I'm going to talk to you about unmanned aerial systems and urban air mobility becoming a reality. And I'll take the approach of talking about the market and going over some technology and industry regulations, and it wouldn't be appropriate if I didn't represent Honeywell by ending with the Honeywell capabilities slide. So with that, let's get started. Next slide, please. So let's talk about the market buzz that's going around. I have just captured in 2 days of information that I get from all kinds of forums: Vertical Flight Society, Urban Mobility News, the UAS News, Twitter, LinkedIn. I could go through each one of those, but I grabbed some snippets of just what has happened this week. We'll talk about, the buzz that's going on in Hong Kong, China, in the Asian market areas. Those are advancing with the regulatory commission, with CAAC, permitting all kinds of waivers to be able to perform actual market injection into the industry. In China today, you can actually, in most of the urban cities, order your food and get delivered by a drone. EHang is actually performing passenger flights today with permission. So it's advancing quickly. The buzz is all over the place. We talk about batteries, lithium-ion batteries in the market. Right now, that is the biggest buzz. Can electrification, batteries actually promote this industry and this market? Everybody is still calculating, will it make it? We're all anxiously waiting for the next technology bump for battery technology. We're looking at vertiports. You've got a ground infrastructure, a whole business economy ready to be just bursting. You got vertiports that are so glamorous, you have a mall inside a vertiport. So there's a lot of market buzz, a lot of market interest. We're talking about Mars, flying drones in Mars. It's a commonplace now to talk about drones. It's going to be a commonplace here very soon to be talking about urban air mobility and air taxi. I mean, I can't wait to be able to get from a dense metro area into another location in minutes rather than hours being tied to, ground transportation. So I gave some more snippets of what's going on. I can tell you on LinkedIn, easily more than 20 daily posts that I'm actually tied to. I've seen it as high as 50 on a daily basis. Very difficult to keep up with this information. So I wanted to give a highlight of what the market actually is reacting to today. So on the next slide, please. Here are some conservative numbers of what the market potential predictions are being implemented today. I'm going to have to do some, oops. Sorry, I can't see my whole screen right now. The column on the right, I'm not able to see, but I believe my memory is correct. It's like 30 billion up in the upper right for urban air mobility. There are what I would consider two main classes in this market potential. You've got the urban air taxi, and then you have like three classes for unmanned cargo delivery. In Honeywell terms, we call them feeder fulfillment and local light parcel, which is last mile delivery. And we are actually estimating what the entry to service will be. All of that is speculation. Nothing is for certain yet. The one thing that is probably the order in which entry to service will take place. Urban air taxi, I'll go and talk a little bit further about, there's still some advances that we need in some areas, especially regulations and legislations. But in the feeder, fulfillment, and light parcel delivery, we're talking about entry to service now. There are many waivers in place locally in the domestic US with the FAA, with many manufacturers, UPS, FedEx, Walmart, Amazon, all of them getting waivers to operate right now in trial exercises, experimental classes, to be able to deliver parcel packages. Everybody is into it right now. Having to have delivery other than Amazon on the same day is really the ultimate goal. And to be able to have this market space with these number of market potential is just enormous. And we all know that money drives results, and everybody is vying for this business. This industry is heavily investing for the future in this new aviation space. So here's just a really high level market assessment, and we could always argue about what the market potential will be. But one of the other things that I wanted to voice is right now, just the way that companies are acting, and they're actually joining forces to be able to have investors more secured, and basically they're doubling down on certain vehicle manufacturers out there. I won't want to go into the specifics, but we've heard about what's happening with the market in the US and in Europe. The investment is just huge. So I wanted to give a high-level overview of the market potential and why really this is becoming a reality today. Next slide, please. Let me give you a little bit about what, if you're unfamiliar with the autonomous aerial logistics, which we call cargo delivery. And down at the bottom of the top section, I am denoting what problem it actually is solving. So today, the regional and movement of cargo from regional hub to regional hub, sometimes you have to do that. Sometimes you go from regional hub to distribution center or multiple distribution centers. By the time it gets to your business or to your house, all of that is normal ground transportation today. Semi trucks, train, and if you're talking international, you're boating it or air travel. So what is the unmanned aerial logistics going to be solving? Well, first and foremost, the low pilot utilization. And I know that that sometimes in our pilot community is a tough one to swallow, but prior or before the pandemic hit, there was already a shortfall of pilots, certified pilots in the industry. As soon as the aviation starts traveling again, we will start seeing that once again surface to the top. When this industry hits the market, it will be unsustainable. So from an unmanned logistics perspective, now you don't have to wait for a pilot to rest, to have the cycle time of traveling to and from the actual locations to the centers, spending nights, overnights, the costs associated with that. And the biggest advantage is you're able to move product more regularly, and there is no wait time, there is no rest time for the drones and for the cargo vehicles. So you're actually being able to increase the logistics, reduce the cost, which is number one for every business agency out there. This is the reason why the FedEx, the UPSs, the Amazons, the Walmarts are heavily investing in this area. Down at the bottom of the second half of the page, I gave you examples of what these aircrafts are looking like. The one on the bottom right, that's the one everybody's most familiar with. That's your average drone that's under 55 pounds today is what the FAA is looking for Part 135, Part 107 certifications. They have payloads capabilities. I put down 5 pounds. We're looking at this industry being more in the 5 to 10 pound area with 25 to 30 mile ranges. The fulfillment centers is the ones that are taking the vehicles and the package from regional hub to distribution center, or even between distribution centers. And there you're looking at payloads of 150 pounds, upwards to maybe 200 pounds and going about 150 to 200 miles. The feeder aircrafts also fully, and I'm talking about electrification here, all of these being electric vehicles. A feeder aircraft is looking to take about payloads of between 1,000 pounds going to about 800 miles. Now, believe it or not, there are a lot of energy being flown in the market for large cargo. Today, I'm showing you a traditional conventional takeoff and landing vehicle that's piloted. And in the future, they're already talking about unmanned large cargo transportations, upwards of 3,000 mile ranges with 15,000 plus pounds of payload. So this gives you a good overview of the advantages for the UAS, the Unmanned Aerial Systems cargo area. So want to make sure I give a good overall view of what that market is looking like, what it actually is solving. Next slide. Now I talk about urban air mobility. In here, the entry into service is not there yet. It's not ready. And why do I say that? There's still a discovery phase going on. Regulations are not complete yet for urban air mobility. The EASA Regulatory Commission in Europe is probably the furthest along. They've actually published special conditions of VTOL, vertical takeoff and landing regulations. They've also published a means of compliance according to that regulation. They are the ones furthest along. Every other regulatory in the world has not published. The FAA is working very diligently to create theirs. They are running through all kinds, and maybe folks on this call are participating in working groups, committees, in order to help with the regulations. So we have a lot of work to do still as far as the regulations are concerned. I also have legislations in here. You see the photo of the vehicle on the right-hand side there flying over in a metro area. You have issues with privacy, security, that folks are actually commenting, which is along with the public acceptance, but we'll talk about that, what I refer to from a different public acceptance, but from legislation perspective is the permission for these vehicles to be able to operate in this airspace. There's still some of that left to be done. That's both at the federal, at the state, and at the municipality levels. And everybody in this industry is working to help and to clear the obstacles for this industry, because everyone is looking for the advantages. Now, what do I mean by public acceptance, other than the fact of what I've talked about privacy and issues? And the public acceptance still today, as we all know in the aerospace industry, is more reluctant to accept these vehicles than if you were doing an unmanned vehicle. And I'm not sure how many times I've had to explain to people that I would rather get in an unmanned air vehicle than an unmanned or unpiloted ground vehicle. just because of not only because of the proximity that you have in ground transportation from one vehicle to the other, but when you mix humans and autonomy together, it just doesn't work. I will be able to go in the sky. Separation in the sky is much greater than it is down the ground. Automation, autonomy is much easier to control up in the air, and still public acceptance is still reluctant to get into a vehicle. I always give the example in the subway systems back in the 60s and the 70s. There was conductors at the front of the subway train, and the only reason the conductors were actually there was to ease the public acceptance that you couldn't have somebody actually in control of the train, even though the conductor wasn't doing anything in those subways by the time we got to the 70s and the 80s. And then slowly they disappeared and nobody cared because it was safe. We will have to go through that. So the other part of the public acceptance is safety. So it's progressing much slower. When you start transporting people and these aircraft start getting of larger sizes and you're flying in urban environments, I'm all for the fact that we have to make sure that we progress slowly in this. The ecosystem also has some time to mature. Are we going to have skylanes? Are we going to have open flight planning, routing for these vehicles? All of that is still under contention and being worked heavily today. Secure, reliable communications, vehicle to vehicle communications, vehicle to ground. We're going to have cases where we're communicating vehicle to cloud. How do you secure the cloud? How do you secure the information in that area? All of these things are still up in question. Vertiports, ground infrastructure, the UTM industry, vehicle battery management. One part of the vehicle battery management that I'm going to talk about is exterior of the vehicle. Do we know that these electrical grids in these cities can support not only electrification of automobiles, but now we're talking about electrification of air vehicles. Now the numbers and quantities will increase, and can the grid in the local area support the charging of these vehicles? That is a big question, and some of them are actually answered for some of the older metropolitan areas. Right now today, all the studies show if you implement this with, let's say, moderate entry into service in LA, the electrical grid could not support the electrification of these vehicles. We will have the same situation in older metro cities as well. So we're looking at a lot of infrastructure still left to be for ground taking. Traffic management is still need to be explored. So the one key element here that I want to emphasize, there's stuff that still needs to be on the urban air mobility. On the unmanned aerial systems, I already said the timing is now. Depending on how quickly we finish the regulations, the legislation, public acceptance, and some of this ecosystem of the urban air mobility will determine what we do. On the right side, I've got some areas there where I'm just talking about now on the technical side, what are still remaining to solve. And the only reason I say it's remaining to solve because there's no regulations to prove that you've met the criteria. I'll speak specifically to what we do at Honeywell. This is where I say this is where all of the smarts comes in and the years of certifying and having reliable, safe products. Being able to do emergency landings, we have the technology to do that. We have nothing to actually certify to because the regs aren't written. If we go to even to EASA today, if we were to certify an emergency landing procedure, they do not have the actual means of compliance to certify to that. We're talking about tracking, we're talking about detecting and avoiding of all air vehicles. We can do that today with the technology. We just have no way of complying with what the ecosystem is going to be required to do. So as far as getting this into the industry is all tied back to regulations. So hopefully this gives you a little idea that where some of the premise, if somebody has heard my previous panel conversations in the Vertical Flight Society last year, you will see that back then, a year ago, I said the technology is ready, and I can still stand to that. The technology is ready. The means of compliance to certify is the problem that we still don't have as to what are we going to actually be measured to. So hopefully that was informative on the urban air mobility. So next slide. Here are the areas that are critical for technology. And here's the ones that I can say it's not just Honeywell, it's other suppliers, and we're ready to be able to provide these services. So we're talking about simplified vehicle operations. If folks are not familiar with that terminology, it's the capability to have the flight controls and the vehicle management system on board, all in one synchronous area to be able to keep the vehicle safe. What do I mean by safe? That the actual pilot will actually be transitioning over into an operator under simplified vehicle operations. So either the pilot or an operator could not put the vehicle in an unsafe condition. You couldn't even exercise a barrel roll. The aircraft flight control system will prevent you from doing that. You couldn't dive the aircraft or pull it up to a stall. The vehicle actually will control itself to make sure that the limits are actually adhered to. So even if you pull the stick completely in one direction, you will go to the maximum allowable turn with that speed and that weight to that aircraft. And so we're talking about simplified vehicle operations. The technology, it's there already. We've been doing it for many years. The integrated detect and avoid sensor and avoidance solutions. This is something that we're actually testing now. We're being able to do, there's essentially, unlimited number of scenarios for detect and avoid. How do you actually provide that you have a safe, operable product? That is always left to question with the regulations. It's one of the things that separates between what is something that actually works and what is something that works every time safely and reliable. That technology is there, and Honeywell's not the only one that has this type of technology ready to be deployed. So we're talking about actuations that are electric, the whole electrification of the vehicle tied with the fly-by-wire. We're talking about potentially electric or hybrid electric propulsion to be able to do some of the larger areas, some heavy lift aircraft, until we get that next step function of improvement on battery technology. Then thermal management. You're going to have people on board with an urban air mobility area, so you got to cool the cabin, you got to heat the cabin. And oh, by the way, that thermal management system can actually be used to cool the batteries. That is a big issue going on right now. For those who have been heavily in this industry, batteries get hot. The energy density being dissipated has to be dissipated in the form of one form or another, and that is in heat. And how to keep that thermal runaway from happening in the batteries, in the packs and the cells is all about cooling and how you're going to actually be able to prevent that. So my takeaway here, that technology readiness is advancing faster than the regs and the laws. Very little is still left to be done as far as technology readiness. But if there was regs in place, I can guarantee you that the urban air mobility will be in the same race as far as unmanned aerial vehicles trying to get to the market space. Next slide. So let me wrap it up with at least what I'm talking about, the three variables that have to come together. Obviously, the market demand is there. We talked about the money. There's billions of dollars in conservative measures right now. The technology readiness is maturing faster. So you add that with vehicle manufacturers, industry players starting to stabilize and become more viable in this market. And every day they're gaining investor strength. So you have technology adding the strength in the vehicle manufacturers. Now we just need the industry acceptance. For the regulations that I talked about, the legislations, and then public acceptance actually has helped with the pandemic. People are more inclined now to accept something, a delivery from drone, because of our social distancing. Hopefully we return to normal sometime and we're not, acting that same way, but it's actually aided some of the help to be able to do and interact with transportation of goods and services, not goods and services, but actual goods and products via a drone. And you add all three of them, technology, the vehicle manufacturers, and the industry acceptance, and now you're going to have this become a reality. And for unmanned vehicles, that reality is today. So on the next slide, I'll have to go through my Honeywell plug. I can't do my own company service and my positions any service if I don't go into the details of what we have here. Honeywell is committed to this industry. We dedicated a new business unit, and I lead the engineering development for that effort. My job is to bring all of the products that we have in Honeywell, which are extensive. You can actually see the individual products, and these are not all of them. These are just the big ones. They're in the middle right-hand section of the slide. Our vision is, I've already spoken to it, the air cargo, the urban and regional air travel. And what we provide is fully integrated propulsion and avionics systems to our customers. That would be the biggest value to our customers, where we do the full integration of the full system. Some of our customers like not to go that way. And so we either provide them an integrated propulsion system or we provide them an integrated avionics system. We've had some customers go in those directions, or they can choose to go by individual products. And you can see there, these are just at the high level, some of the areas that Honeywell has today that is ready to invoke into the cost, size, and weight, power requirements of this industry. We are still working to even get better at some of those. But you can see the individual products that are there. You have pictures of some of our, cartoon figures down at the bottom. Without having permissions from some of our customers, it's easier to have the renditions of these graphical images than going through and having each of our customers posted in all the websites. So this is, the future. This is the reality of what's coming, not only today in the unmanned area, but what's coming very close to tomorrow in the urban air mobility. So hopefully, I ran through this a little bit quicker than expected because I thought we were going to have live questions in there. So with the next slide, I want to thank everybody. And at this point, Colton and Chris, I could open it up for questions and hopefully provide some good answers.
Sounds good. All right, I will probably go straight into these then. We did get a couple during the early part of the introduction, so some of them did come prior to most of the material that has gone through the presentation, and then we have received several towards the end of it. So looks like there is close to 7 or 8 of them, so we will just kind of go down the list, starting with submitted by Gabriel. Will it be safe to start at urban areas, or do pilot tests and sustainable start at rural or island areas before moving on to the urban areas flying above people and property?
Yeah, so definitely we'll be going into the rural and urban, before you go into the urban areas, you have to do many types of trials and testing. And so even in islands, yes, absolutely. There's many trials for experimental tests conducted today across islands, and that's in the global span as well, not just domestically. So there's a lot of things going on in the Asian market right now, trying to get some more testing done. Hopefully that answers your question, but yes, it is correct. We'll start with low dense populated areas before we go into the denser areas.
All right. Submitted by the same user, Gabriel. Should there be centralized landing stations similar to the bus train stations we have nowadays, or more quantity of spread and decentralized landing pads?
So the terminology is being used for urban air mobility is vertiports, and those vertiports will be strategically placed to be able to help the market with how long the paths will be in the sky lanes from vertiport to vertiport. They're going to be properly spaced with major areas and metro locations to where's the congestion of the public, where the people need to get to, downtown areas. So all the vertiports will be strategically placed, not only by the range of the vehicles, but also by being able to control we have GPS availability. We need to have connectivity, both from SATCOM and cellular technology. So we need to be able to have those vertiports strategically placed. So to answer the question, there'll be more than or equivalent to a bus stop. Probably not as much to a bus stop, but definitely more than bus stations.
I keep disappearing on my panel. I have to keep finding that one. So, okay. So the next one, submitted also by Gabriel, is there a lack of infrastructure to pick up, drop off, and charge EV tolls?
Yes, I mean, that infrastructure does not exist today. That's part of the maturity of the ecosystem that is still yet to be taken up. You know, there are many of our own customers that are going to be investing not only in the local, but you know, ecosystem, but in the development of that ground infrastructure. That is still left to be seen as to how many people are going to be entering that market. And so when it starts being you know, a large entry area, then we're going to start seeing most. There are some areas, you can go to Singapore, you can go to different areas in the globe that have actually been marketing their vertiports and what they're going to be doing with those areas. So yes.
Okay. The last one from Gabriel. Urban is a buzz trend and still has a lot of competition, even if a longer duration. But wouldn't islands like Bahamas make sense since there's no other way besides by sea?
Yes, that would be great if they can make the distance. So that's still to be determined if they can actually make that distance. But for unmanned vehicles, they're already getting, you know, as I stated before, there's already packages being delivered by drones in the island. So the question is the distance. Can they make the distance with the payload for transporting people? But yes, that would be a great entry into service area for the urban air mobility.
Okay. Thank you, Gabriel, for all of your questions. We're going to go over now to a couple of questions submitted by Rick. This first one is, are the UAM vehicle designers finding they need to measure airspeed at low speeds? If so, what kind of measurement devices are they favoring?
So you've got the traditional airspeed methods for air data, you know, your standard pitot tube. You're measuring also with GPS locations. You're measuring with ground locations, alternative navigation methods. So right now at low speeds, it's basically, you know, from what I'm able to convey as to what the technology is being able to provide, you're going to use all means to measure at low speed. That's the difficult part. But you can use different ways to be able to calculate that. So hopefully I wasn't too generic there, but your air data would be your most common method. And at very low speeds, you would use alternate means with either GPS or land based locations.
And if that was too generic, and if you want to ask a follow-up question, Rick, you are more than welcome to submit another.
Please.
To which he can answer anyways. A little more from Rick, at least for now. There seems to be a lot more energy and money going after UAM rather than in cargo. If the time is right to get the cargo ecosystem going now, why do you think there is not more energy going toward it?
Well, I mean, you always put the energy where the big dollars are, right? So urban air mobility actually has the demand for the biggest dollars. When you start transporting people, you start getting the certified aircraft, that's where the big investments are. You will start to see that trend changing here very quickly as you start having more operations. Your investment in the vehicle is also depending on how much your revenues will be. So, you know, this is the reason why the last mile delivery drones, they don't cost as much, and therefore the service and the operations for that don't cost as much. So the more your vehicle maintaining, cost of vehicle, certification, the more the actual service will demand. So that would be the whole delineating factor. But you know, as we start seeing the middle mile and feeder aircrafts take off, there's going to be plenty of market revenue there. So we'll start seeing energy flowing to that in the next coming. In fact, in 2022, I predict in 2023, as they start entering the market, we'll start seeing a huge influx into that market.
All right, we're going to go over now to Jeff. With respect to all electric systems, what are your largest challenges, or what are the largest challenges still need to overcome?
So obviously, it's the energy density to be able to carry the payload. It's still right now the challenges. If the vehicle is in a hover mode or in last final landing, that's where the highest energy consumption takes. So trying to prevent the vehicle from being in a hover Takeoff and landing needs to be minimal. Get lateral transportation going as quickly as possible. Maintain altitude as much as possible. That's why you're trying to get elevated vertiports. If you're going from ground to some flight altitude, you're dispensing a lot of energy. So to us, the biggest form is to be able to predict. Now, Honeywell's not in the vehicle manufacturing business area, but we do have to be able to determine whether you have enough energy to be able to make the leg that you're actually committing to. And in order for that, we have to calculate the flight plan consumption of how much energy density is required to make that mission. And so the biggest obstacle to still overcome will be the battery and the power dissipation. And then secondly would be controlling that thermal. But you know, we're looking at also environmental conditions that would be imposed into that industry. So I think the third priority would be what exactly will be the right environmental qualification criteria for these vehicles, because that's driving a lot of the cost today, if it stands to be the same as what EASA is trying to put out into the industry today. So hopefully that answer, I gave you 3 priorities, but the number 1 is basically the energy density of the batteries. So if there's any chemical engineers out there, that's what you should be focusing all of your time right now. And you could probably be a millionaire if you solve the next technology leap in batteries.
Yeah, battling energy density just from a drone standpoint, I've been frustrated for years with the small amount of time I actually get to fly anything. I would love to see something a little bit bigger, but this is also much smaller scales.
Oh yeah, so you can relate to, and I mean, it's like what we always say is enjoy that first flight because you'll never go as far again. So, you know.
Too true. All right, Scott Swinzik. Maybe it's just Hollywood, but technology like this scares him like taxi cabs in The Fifth Element or drones in Terminator and Skynet. So how are we preventing hacking into these unmanned system networks?
So that's cybersecurity is up there with us. Number 2 to safety, and what they both play each other. It's a cat and mouse game. We are invoking every cybersecurity measure that we know of today. But as you know, as we actually develop defense mechanisms, there's something else that either is able to break it or determine vulnerabilities in it. Honeywell is committed, as well as other suppliers in this industry, to be able to put the highest measures possible in security. There are different, and this is one where I will not cross because it is critical business knowledge in which I would be divulging as to what leverage or principles we're using in Honeywell. But there are schemes that you can do to be able to protect yourself at all costs, even if your traditional cybersecurity methods are not strong enough. So we comply with all of the normal protocols today. If most of you have dabbled in that, the security protocols that we have today with your cell phone are highly secure. Is anything 100% foolproof? No, but that's where we actually have to take on other measures. And unfortunately, unless you're working with me and my company, I wouldn't be able to give you what that secret sauce is, because on that one, I do have to keep that a little bit tightly lipped.
Totally understandable there. All right, moving on to Colin. Is Honeywell developing their own UAV?
No, I wish we would. I've tried to lobby for that. It's much more affordable than creating your own business jet or air transport regional aircraft. But as it stands today, Honeywell is committed to just providing our products and to our suppliers, to our customers.
All right, and I will let you know, at least as I keep going through this list, that we've still got about, I think, 15 or so more questions. There've been a lot asked in just the last 10 or so minutes, so we'll keep going through them until we run out of time. So,
sure.
Next one is from Marissa. Hector, great presentation. I just read today that Korea expects to commercialize UAM and AAM by 2025. What will it take for the U.S.?
Legislation. What it will take is for the FAA to continue being what they're doing today. They are taking some bold measures to move faster than they ever have before. We see the FAA reacting to the demand in the market. They are building new departments in the FAA organization to be able to address this quickly. We are working with them and all the committees to be able to help with the regulations. But number one thing is regulations. As I've stated, we provide the technology today to be able to do everything that's required. It's just a matter of being able to get it certified for entry into service, which is the hardest part. Without no regulations, we can't get there.
All right, and I hope that I don't go through and butcher this name. Our next question comes from Lavier Rice. Is Honeywell building UAS, UAM vehicles or just turnkey subsystems?
No, we're just doing products and services. I think that was a very similar question to the previous one. I wish we were doing the vehicles, but we're not.
Yeah, fair enough. All right, go back into this. From Connor Briggy, what kind of flight safety regulations are you facing, specifically when it comes to mechanical design of these aircraft? There are no people on board, but they could definitely pose a threat if they fail in a well-populated area.
Yeah, very good question. So we still have to follow the same principles. We still have the same certification methods today for an engine in general aviation. So if you have a Cessna 182, we still have to comply with the same rigor for reliability and durability. Today, if I throw out some numbers, if you're a private pilot and you're flying a Cessna, your engine right now is 10 to the -5 from a fail perspective. Our electric propulsion motors, our electric motors, they are at minimum 10 to the -5. And this is the criteria that I keep talking about, and this is for probability of failure. Right now, it depends on what the means of compliance will be for all of these aircrafts. Right now, EASA is looking for things much more stringent than that, which is not a problem for us. The only problem is it increases the cost of the product, and therefore it's translated to the vehicle, which then is translated to the consumer, and then at some point it makes it non-viable. Almost had to sneeze there.
Feel free to. Another follow-up question by Connor, actually. Do you anticipate long-distance automated cargo aircraft outpacing the up-and-coming autonomous trucking industry?
Depends how long distance the reference was made to. If it's for the 3,000 mile, no. If it's for the feeder, when we're talking several hundred miles, yes. I think that will outpace normal ground transportation for autonomous vehicles. It's just going to make it much more viable. It's still very difficult challenge to be able to do it in ground transportation. And now I'm getting out of my own lane here, but in autonomous ground operations, if you can control the actual highway or the roads that these vehicles travel in, where only autonomous vehicles are able to operate, then the potential is there. But you can just imagine the infrastructure required for that. You'd have to create your whole separate new highways, separate new cross interstates. It would be very difficult to do. So my prediction, at least for the feeder, unmanned vehicles for several hundred miles, they would actually be probably coming out sooner than any unmanned large cargo ground transportation.
Okay. Down to Rick again. I think you mentioned early on that the issue of performing a controlled landing after a failure has been solved for an eVTOL aircraft. Could you elaborate on that?
I'm sorry, repeat that again, Colton?
I think you mentioned early on that the issue of performing a controlled landing after failure has been solved for an eVTOL aircraft, electric vertical takeoff or landing. Could you elaborate on that?
Well, sure. I mean, so let me go into, these vehicles are, at least from a system that you have flight controls. They're all fly-by-wire. They're all in the aerodynamic principles of that aircraft by its CG, by its loading, its demand, is taking wind into consideration. So if one of the propulsors go out, let's say you have 6 propulsors and one of them goes out, there is no human being that will know how to control, 5 other propulsors to be able to compensate for that one. When you have a single engine, or you have 2 engines, or even when you have 4 engines mounted traditionally, actually you know how to control it. A human actually can operate that. You can actually feel what you have to do from a pilot perspective to be able to compensate for when you have an engine out. And when we have an eVTOL aircraft that has multiple propulsors, and we're talking more than 4, then at that point, you're relying on the system. So the long answer is the system is totally in control and being able to know how to compensate the other propulsors by either rate, pitch, to be able to compensate for it. Once you know what your particular issue is, and all of these systems will be highly censored, so we actually know what exactly is going on. First thing is you being able to, depending on the failure of the actual motor, you either turn it off or you leave it free flow. Then you have to compensate with your flight controls to be able to do the other one. You automatically engage a landing operation, emergency landing. And so it goes back to what I had stated before. We have the technology to be able to designate what your emergency landing zone. Every leg for an urban air mobility today, the plan is to have an emergency landing in each major leg of the flight path. Now, let's say you can't make that emergency landing zone. Our system will actually know whether you have enough battery, you have enough control left in your system to be able to pick another landing area. Now, at this point, depending on the criticality, we have systems on board with sensors. We have some very small, cool digital phased array radars that can actually scan the ground to be able to depict where you have level ground, clear ground, to be able to designate a landing area for an emergency condition. Otherwise, you would go to a designated emergency landing area. And it gets much more complex from there. But what I described to you right now, the flight controls will have very high integrity. The probability of the flight controls failing is highly unlikely. We're talking to any probability factor greater than 10 to the minus 9, which for all of you who are on this call, mostly are technical in nature, the probability of that happening is not likely at all. So your flight controls will still be operable and will be able to designate what you are. Now, if you have 6 propulsors and you lose 4 of them, depending where the 4 are and depending what you have left, will always depend. So it always depends on the nature of your failure. But the failure conditions is what we've been doing for decades at Honeywell with complex systems, and being able to do the flight control laws for these vehicles is no different. It's just now we have the capability of being able to do very, very fine tuning with the full electrification, where now you're not actually spinning an engine, you're actually controlling it with the electrons you're actually flowing through with the current. So hopefully that answered your question, but as you can tell, when we start talking some of the technical stuff, that's when I started getting a little happy and smiling.
I think most of these people online today would totally agree with that.
Absolutely.
Another one from Lavere, and actually as we start getting out there, we are about 5 minutes out from wrapping the rest of this presentation up today. So because of the number of questions, I apologize to everybody who has asked one that may not get them answered. Again, we are asking in the order that they were coming through, but we'll try to get through as many of these as possible. So again, back to Lavere. For OEMs, how sustainable will those relationships be for the supply chain of OEMs?
So how sustainable they will be for which ones, Colton?
The supply chain of OEMs.
Oh, well, I mean, that's just normal supply chain logistics that they do today. The good part for the OEMs, the good part for this industry will be numbers that are much higher than ever before. So we're talking supply chain, when we're talking about, maybe several thousand of a particular type of aircraft. Now we have the potential, we're talking hundreds of thousands, worldwide, and of different classes. So from a supply chain perspective, it's going to actually increase the market. It's going to increase, capabilities and demand. It'd be fantastic for aerospace. We're finally going to be talking about numbers that would be comparable to ground transportation. So from a logistics perspective, in fact, we probably would be competing with the automotive industry. But for aviation, this will be a wonderful breakthrough. And this is the reason why the market is so strong, and the potential is going to be there because, just the upside for all this is just tremendous. So hopefully I answered your question on that one, but the logistics will not be any different. It'd be better than it is today in traditional aerospace.
All right. One more from her. Will these subsystems be subject to ITAR?
Yes, there are some. Very good question. In fact, we are having some of those issues today with our fly-by-wire system in China markets. We're talking about our radar also having sensitivity of being also from an export compliance perspective. So there is some technologies that we're being very careful as to how we're going to implement them into the market. But there is some sensitivity, but not really from the product itself. In the know-how of how to have that capability is where the ITAR and export compliant restrictions are coming from. The product itself will not have ITAR restrictions on them.
Okay. From Melissa, is Honeywell working on or partnered with any other companies to identify the infrastructure and associated flight hardware needed to support autonomous flight?
Absolutely, yes. I mean, we are partnered with many for the infrastructure, and we're trying to figure out how broad do we want to be able to touch the ecosystem, because with our capabilities and our systems that we provide on these vehicles, being able to touch a greater ecosystem is much easier. Our technologies, how we get security into the cloud, into the web-based, ground operations, all of that. It's just a matter of how wide does Honeywell want to go, and from my perspective, I want to have it a little bit more controlled. If the aperture is too wide, it's very difficult to service everybody. So hopefully that answers your question. We have the capability and the capacity to probably do more, but we're trying to be focused.
All right, and I think we're going to ask this last question for the length of it is and for the time that we have left. So from Dan Newman, all enduring successful business models find a balance between risk and rely on balance between risk and an environment model when you have identified the issues associated with responsibility and liability regarding incidents and mishaps. I think that's actually the question there is, have you identified the issues associated with responsibility and liability regarding incidents and mishaps?
So yes, absolutely. I mean, Honeywell has been in the liability and risk assessment ever since we built our first gyro for an airplane, right? This is the reason why companies like Honeywell, and we're not unique, there's many out there that work very diligently to be able to provide to our OEMs safe and reliable products. We go through great lengths and measures to be able to assess the risk and vulnerability of whether we want to enter certain areas. But we do flight controls. We do flight controls for complex aircrafts. We do it in the military for very complex aircraft. We've been doing it, and there is no other higher risk and liability than flight controls. And so it's a matter of, do we do those assessments? We do, and we make sure that we have the skill set and capability to be able to do that, to take the path of least risk. Good question. They've all been great questions, Colton.
And quite honestly, I'm happy that with the time that we had on this today, that we were able to take this all the way through for the full hour. Now, I am confirming right now, we did have somebody request a certain question from one of our organizers. I wanted to clarify that, but we might be running out of time here. So it might be something that I send you as a follow-up, either via an email or another means. So I think we will table it for now, just to be respectful of everybody's time. Again, I realize that it's about 8 p.m. over there on the East Coast. It's only about 5 p.m. here in Arizona. Again, Hector, really appreciate your time today and your willingness to come and talk to us in the society. A message to all of my organizers: I thank all of you for your willingness and availability for making this meeting happen today. It's been wonderful collaborating as usual with everybody. We look forward to the next one. Whatever we can do to support, please let us know. And we will, of course, spread the word on the upcoming next virtual talk put on by the Redstone chapter that is looking like it's slated for April 22nd. If there are additional questions that we would like to get answered to Hector, we will have to figure out the best way to get those answered. Also assuming, Hector, that you are willing to take all of those questions. We don't want to bombard you with a whole bunch of emails, so we will figure that out. But in the meantime, if you did have a question today that you really would like answered that we didn't get to, please contact us, please have those submitted, and we will see what we can do to try to get you guys an answer.
Well, Colton, I thank you, and hopefully this was beneficial to all. I love all the questions, and it's a good thing I finished it, my prezo early.
It's perfect. I mean, right. There's still a good, again, 10 or 15 questions that I didn't get to here just in the end. So
excellent. Well, good. Send them to me, Colton, and I'll do my best to answer them, okay?
You got it. I really appreciate your time again, Hector. And again, thank you everybody for joining us today. Have a great evening, and we'll see you on the next one.